Full Throttle RC, presented by Warehouse Hobbies. I'm your host, Tony Castronovo. This is episode number 5, part D of our engine building series. This is the final part on how to modify an M5 Zenoah engine. Welcome back, and I guess you guys thought I was going to make you wait a couple, 3 weeks. No, not really. I want to get this behind us because we got bigger and better things to go on to. So let's get started on completing this modified engine. We'll see you shortly. You spent a lot of money on your model boat engine, your Zenoah or equivalent engine, and now it's time to purchase oil. Some manufacturers say, hey, use anything you can find that's two-stroke. Use something for a string trimmer. Absolutely not the case. Warehouse Hobbies produces hundreds of engines, thousands of engines over the years, and we see it firsthand, oil-related failures, and it's unfortunate, especially as I've been pushing this particular brand, AMSOIL Sabre 100-to-1, for almost 25 years now. We use this oil religiously and sell it and have been selling it since 1984 because we found it to be one of the only oils that can be mixed on a richer level, yet does not carbon up and gives great lubricating properties to the engines. This is very important, especially on a mid or modified engine where you would run you'll need to run a higher context of oil, 25-to-1 in our case. So AMSOIL 100-to-1 does the job. The 100-to-1 means that the oil is designed to run 100-to-1 ratio, but that's too lean for our engines. So we found that by mixing it 32-to-1 for our standard Zenoah engines, for instance, it works fantastic. And modified engines, M5 or M6, bumping it to 6 ounces per gallon or 25-to-1. This oil is superior to anything else I've ever tried. And we sell it, and we also have it available now in quart sizes at a very reasonable price. So AMSOIL 100-to-1 oil Sabre mix is my recommendation on oil used in model marine gasoline engines. Okay, before we get started, there's some certain tools you're going to need to perform these operations, and they can be done by hand, like I stated in the earlier show, or on a machine. So if you have the skills and have small milling machines maybe available in your workshop, simple jig fixtures can be made to do this. However, I'm going to show you how to do it by hand, which is something we used to do many, many years ago. Before we start, the most important thing, if you're going to be using any type of machine tools, is we need these safety glasses. So make sure you have a good set. Motor tool is necessary with a quality set of cutting bits designed to cut aluminum. I choose the air tools, but a Dremel works fine. Just got to be a little bit more careful how you dig on them. They don't have the power that these put out, but we use the air tools in this case. I also have a quality set of bits in a different array that will actually make several different types of cuts. The majority, the bit that I use most frequently is a 1/4 inch with a round ball nose. This is your average cutter for this job. Okay, next, we'll leave these off to the side for engine assembly. You'll need your degree wheel. This is very important. Remember, we went through this on the show on how to use a degree wheel, so you might want to go back and watch that episode and get refamiliarized with it. Okay. We're going to use the 2 different cylinders again. We're going to, for display purposes, we're going to use the home light because I can show you the cutaway, and then obviously the Zenoah. And we'll get Chris to work closely with us and zoom in and out here so we can show you the actual porting. I talked about the M5 engine. That was the particular one that we manufacture on a standard basis here at Warehouse Hobbies. It's very user-friendly, very reliable. Whenever you do any kind of engine modifications to increase top end, there's a little bit of bottom end you're going to lose. There's a little give up there, give and take. However, the M5 numbers are excellent for sport performance boaters. They're going to give you a noticeable difference in improvement. You can easily see 5 to 7 miles an hour depending on what type of model you're using. The power output is roughly, you can get 6.7 horsepower gain, as much as 1 horsepower with the right tuned pipe. And we'll get into all that later. We want to finish up this episode on how to modify engines, then we'll move into applications of tuned pipes for this particular engine. Okay, the most important procedure on modifying an engine to gain RPMs is the exhaust timing. And in this case, we'll let Chris zoom in. Again, we're showing the home light here. Let me get a pointer here so we can see your exhaust port right here. Okay? What you need to do to make an engine more efficient is to get the exhaust gases out faster. That means increasing the timing. And when I say increasing the timing, we're going to increase the height of the window up towards the spark plug, this direction. Okay, now there's several different numbers to do this. You just can't start digging in there without knowing where to go. Generally, I can give you guys some hints on a Zenoa. Anywhere from 88 to 90 degrees works really well. Those are pretty good numbers for exhaust. Okay, so this is where your degree oil is going to come in. You're going to have to reset it up like I showed you in that episode, and then do a little bit of cutting, put the engine back together. Don't forget to put the base gasket on it because you need accurate numbers here. And you continue to do so until you reach the determined height that you want to go on the exhaust. Okay? I'm going to give you a couple different rules of thumb on this too. You can also widen a port. There's nothing wrong with widening a port. Okay? The only concern about widening any type of a port is follow this rule of thumb. Never exceed 1/3 the diameter of the piston. Because what this does is if obviously the wider we go, the better. As long as we're not interfering with side transfer ports, that'd be fantastic. Except for the fact that you've got too much ring expansion, too much pressure on the ring. And if this happens and you go too wide, you allow the majority of the ring in the exhaust window to relax. And this ring, as it relaxes, could literally get caught up on the lip of the port. So over time, as the ring relaxes, it could snag there, and then that causes catastrophic failure to the engine. So we always follow the rule of thumb: 1/3 the diameter of the piston would be maximum for the exhaust port. Okay, now let's get into actually machining. We're going to use a die grinder. We're going to put our safety glasses on. And basically what you're going to do, this takes a little bit of hand skill. What you're going to do is you're going to come into the cylinder, okay, and you're going to raise the ports physically by removing material. You got to be very careful not to remove too much. So you want to take nice slow passes, and you want to set the cylinder up to where you can get a good visual of what's going on. I like to hold it firmly in this hand here, left hand. I'm right-handed, and opposite for you guys left-handed. And come on in, Chris, come in and get an idea what we're doing here. Zoom right up in that cylinder, and you can see how I'm going to be cutting this. Okay, now, at the same time you're cutting into the cylinder wall up, you have to make sure that your cutting bit isn't doing any more damage anywhere else that you don't want it to be cut. So I highly advise not touching the outside of the port. Keep the tool from cutting that. Let's work on the inside first. So we'll go in, we'll go to the corner, and you have to have a steady hand for this and be prepared and practice because it can get away from you. And you want to set the speed of your tool where you can get a nice cut across and raise the port a little bit. Okay? Keeping this particular angle like this. Now, let me show you on the home light cylinder where it's got a cutaway. You'll see, let's do this a little backwards here, you'll see in essence what we're doing. We're going to go upwards on the port across and raise it. Now you want to do this until you get fairly good at knowing how far you can go. Take a little bit off at a time. Clean the port really good. You want to make sure there's no fragments on it at all. To do that, use some 600 wet sandpaper, some WD-40, or any type of a spray oil like that. Get yourself your sandpaper, and always work the inside of the port to make sure that there's no fragments on it, because when we reassemble this engine, we don't want to scratch up the piston. Now you want to clean it, reassemble the engine, and put your degree wheel on it and see how far you've gone. Hopefully you haven't gone too far. So you want to take incremental movements up until you get the hang of this. Once you've done a few of these, you'll know how far you can go and get very close, and then go and make your fine passes. But basically, to reiterate what we're doing, we're going to go into the port, we're going to cut upwards and straight across. We're going to raise the port and try to keep a good steady hand and a good straight cut. You can always go back with a small set of files, hand files, like a flat file, reach in there and straighten your straighten any waviness that you might have on the port. Also, you can use a round file and clean your edges. I like to radius the edges. I'm not going to get too far in depth with types of porting because there's all types of stuff. There's called hi-hat porting and things that you will learn when you get experience with this. What I'm showing you here is exactly what we do to the M5 engine. Okay, and I think we run it about 89 degrees from the top dead center to where the piston opens. That is a good number. Okay, I don't advise doing the intake ports now. The intake port runs fine. As you deck the engine in the beginning, remember when we went through the decking? I failed to mention this. You drop that cylinder down, what, 25 thousandths of an inch, which also dropped the intake port down. Okay, the intake port is designed to make performance. You can go down with it. You want to have the fuel coming in and have a longer duration of air and fuel for that port. But for a sport engine, if you leave the port alone, it'll work much better. You won't lose your idling. The engine it'll have good characteristics for a clutch. Whereas if you took your downtime, we call it, or exhaust intake port down too far, you would tend to have a much higher idle to sustain the engine's operation, and therefore it could easily stall on you, and the clutch would be rendered useless. The clutches our clutches are designed for 6,500 RPM. So if an engine has to idle it at 7,000 to sustain operation, the clutch is a moot point. Okay, the next thing, you're going to be putting this engine together and taking it apart several times until you get the feel of what we're actually doing here. And I highly recommend this. And this goes for when your final assembly and all your trial fits to see if your timings are correct. Some type of an engine assembly lubricant is very important. We sell a specific product designed for engine assembly, and if you don't have this, at least use like a 30 or 40 weight automotive oil to do so. And what you want to do is, as you're putting the engine together, take a small amount, drop, smear the cylinder, smear the piston, reassemble, check using your degree wheel. And the reason you're doing this is so you have no problems with scratching the piston with any type of marks, machine stuff left in it. It's just a good practice, guys. Every engine we manufacture in this company they use engine lube before we put them together. Okay, so like I said, you're going to be putting it together several times, taking it apart, checking your timings. All right. Again, we're going with the M5 engine, and before this show's over, I'll touch a little bit more on intake timing, even though we're not going to do it to this particular one. Okay. Also, when we lowered this cylinder, we also affected the transfer timing a little bit. We dropped it down. But 25 thousandths of an inch is very insignificant to transfers. I found it makes a very insignificant, unnoticeable difference for our application. So we're going to leave those as well alone. Okay. Very important. Let's get to assembling an engine. Let's say that we're right. You've checked everything. You've double-checked everything. Your exhaust timing's fine. Your decking is right. Everything's right. Let's go back and use our home light engine here. Okay. Another great product. This is called K&W Copper Coat. Let me tell you how I was introduced to this. I've used this on my race cars for years, and we've had issues over the years where we'll build high horsepower engines that they have a lot of compression, typical for blowing head gaskets. And let me go back. Let's go back to the two-stroke engines where you've got base gaskets just like this, or the VW engines, which are notorious when you build power. They're not designed to make 150 horsepower. So there's all kinds of crankcase pressures that you're dealing with that aren't normally there. So we tried all kinds of gaskets. Well, I got turned on to this stuff many years ago for taking standard gasket material, and you take this K&W Copper Coat, which we buy this at Napa, but I think it's probably available at most any automotive store, and we are just starting to carry this now, so we'll have this for sale soon. You take your standard gasket, and it's like spray paint. You shake it up really well, spray the gasket, give it a thin coat, hold it with a needle nose, turn it, give it a thin coat, let it sit a couple seconds, and go back and give it a nice coat of this material, and then hang it. I usually let them dry for about 5 minutes, so they're just tack-free actually, so you can handle it. Then carefully take the gasket, apply it on the block. Okay, put your piston in, and then carefully install your cylinder and bolt it down. This product is unbelievable. it makes such a good seal between the case top and the bottom of the cylinder that when you remove this, it normally tears the gasket in half. And like I said, one of the biggest problems we had with the VW engines was so much crank pressure that it would actually weep out of all the gaskets. We would use everything from silicone to, and when I started using this stuff, those problems went away. So this is a fantastic product. Okay, we reassemble the engine. We use our engine lube to do so. Okay, and we're ready to go. Remember, very important, before final assembly, I want to go through this one more time. You've concentrated on working the exhaust port, so between fitting that piston and checking the timing, every time, don't forget the 600. Anytime you make a move on that port, go back up there with some 600 and work on that a little bit. You're not going to affect the chrome with 600 paper, but you're going to take any sharp edges off. There cannot be sharp edges or any type of a chrome or material left that can snag the piston. That will cause a scratch. When you're putting it together also, be sure that you identify the piston. Remember, the arrow on the top of a two-cycle engine points to the exhaust, and that has to be. If you don't and you put it in backwards, that means that you have no ring support where the pin is on the piston, and that ring where the two ring pieces meet is now in the exhaust port. And what inevitably would happen over time is, remember I told you about the expansion, it'll snag the ring on that side. So all pistons on two strokes that I know of are identified with an arrow pointing towards the exhaust port. Okay, engine's back together, everything's tightened down. Okay, and we're almost ready to go. In a couple seconds, I'll show you how to finish up.
Warehouse Hobbies Enforcer Vision product review. Today I'd like to show you and demonstrate the new popular design Enforcer radio box. Actually not so new. Believe it or not, I designed this back in 1987. Let me show you how this works. To display how the radio box installs in a standard conventional boat with 5-inch rail spacing. You'll notice that the box is very unique in design. It has two ledges. These ledges rest on top of the stringers. It also allows almost 2 inches of the box to go down below the stringers. This keeps the servos down low and also battery pack down low, keeping your center of gravity low. Exactly how you want it in a model boat. The radio box then fits on the stringers. It's shown like this, and it's secured in place with 2 screws. A clear lid is provided that drops into a recessed area, and regular radio box tape is applied to form a watertight seal. When you purchase an Enforcer radio box, you not only get a pre-cut lid, but you also get a pre-cut servo tray. The servo tray is designed to hold 1/4 scale large servos for steering, a standard for throttle, and you'll notice how the box is designed to allow for a 5 sub-C cell nightcap, which would last 4 to 5 hours. We truly recommend that for the large boats. There's also a place for the receiver, which can be mounted in this area or anywhere on this open area on the planes. Just last year, we chose to make a change in the manufacturing method that we have used for the past 20 years, which was thermal forming, or commonly known as vacuum forming. This served this purpose for many years and made nice parts, but I wanted the best parts. Now we make these new boxes by injection molding, which yields exact product reproduction. It also promotes exact plastic thickness. One of the coolest things is that we got to choose the color, or in this case, the lack of it. I thought it would be great if we could see through the radio box and show off our handiwork. So we molded these boxes in a see-through blue pigment that really looks great. This also enables you to view all of your radio components and hookups, a truly new concept. It's still constructed in durable ABS plastic and will last for years if properly cared for. This box will fit all Enforcer boats and many other manufacturers' hulls that use standard 5-inch inside-to-inside stringer or rail spacing. We offer a full-size description on our site. Just click on Radio Box to find the link. Our radio box has been copied by other manufacturers, so we know that it must be the best. But only we can offer the original Enforcer radio box, and now it's injection molded. So why would you even consider an antiquated copy? Give us a call today to get the genuine and original Enforcer radio box in your boat.
Okay, welcome back. Okay, before we finish up with our M5, let me touch a little about intake and transfer timing. Okay, and like I said, I'm not going to get into the numbers on that. If you want to experiment, that's fantastic. It's going to take a few cylinders and a lot of testing, and possibly, quite possibly, some of the numbers are on the internet. And if they are, I would share them with a few other people that build engines to make sure that they're correct before you start cutting into $50 cylinders. Okay, the intake timing, again, let's use the home light in this case because we can see it better, okay, is opposite of the exhaust. What you want to do is you want longer duration to pull fuel and air in, gasoline and air in. So you're, in essence, rather than raising it up, you want to bring it down, okay? And by bringing this port down, you'll increase the duration of gasoline and air intake. This also means that you will start to cause erratic idling, a little bit where it's going to have to, the engine's going to have to idle higher. The engine has a tendency of loading up. This is a term that we probably experience, but some people don't know. Loading up means you're putting an abundant amount of fuel in the crankcase, and then when you nail the throttle and let the air in, it cannot burn. It throws that fuel up into the transfers and into the cylinder, and it can't burn it. And the engine might just stumble and stall. That's a common term. And too much intake timing at too low of an RPM this will be indicated by this. And you'll find that an engine with a lot of downtime or lower intake timing will have to generally run at a much higher RPM. So I really recommend that for engines like our M6 competition engine. There's a lot of intake timing. And we do a little bit more exhaust, and that engine needs to run with the right carburation, the right tune pipe, and obviously it runs better without a clutch. I try to push people away from that with a clutch because, as I said, your idling is higher than where the clutch disengages. So we don't want to go too far into that. I've given you enough information now to get into doing engines and to learn how to do them with hand tools. Okay, machinists and experienced engine people have probably graduated from this and are using equipment to do it, milling machines, where there's fixtures, where you can, like we do, we physically bolt a cylinder, let's say, on a specific fixture, and either they're on a CNC machine which has a program, or in some cases on our high production engines like our M5s, they'll be on milling machines that will go in and do the whole job all by itself, and then index, turn the cylinder, come here and do the next port. This is how we do our higher production engines, where your hand-worked engines, like your competition engines, would be taken from that stage, and then maybe a little extra work is done by hand to smooth things out. I also like to work the square port. That means I like rectangular porting. As long as you have good round corners, that's fine. You try to avoid sharp corners. Okay, we want to make it easy for that ring to make the transition on an open port. So if you look at most of my work, or you see it over, you'll see most of the ports are square. Okay, and you can see that here on this particular engine, Chris, if you want to zoom in. Okay. Okay, we have our M5 engine all back together here, and we're ready to go. We've used engine lubricant to put it together. We've checked it. You might want to check compression. You'll be amazed, you guys. The compression on this engine now should be somewhere around, way better than 160, about 170 pounds, maybe 180 pounds. And by getting a handheld compression tester and holding it and securing your engine and pulling it, you'll notice the difference just pulling it. You'll get that thud thud. Also, when you have a high compression engine, it's indicated by a popping sound. An engine making a lot of compression will give you that pop, 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 pop sound to it. And the response is incredible. Okay, now that we've done this, it is also important that a tune pipe is used. The wet pipe that I designed many years ago, the Pro Wet tune pipe that we inject water into the pipe, with this particular timing will work fine. But if you were to go further with it and start doing intake timing and maybe raise the exhaust slightly more, or maybe put a hi-hat on it, or start doing some transfer timing, you'll find you'll have problems with that pipe. It'll give you, at that point, we really need to get into a serious and properly manufactured tune pipe. And when you start getting into that, you'll start using either a 2-inch band pipe or on a competition level. So with the work that we've done here, you can get away with a Pro Wet pipe system. You can get away with a standard conventional tune pipe would work fine. Okay, I'm going to just get into this slightly today because we're going to dedicate an episode on it in the future, and the episode is going to be about tuned pipes. So give me a second, and we'll come back, and I'm going to give you a little bit about tuned pipes. Okay, let's talk a little bit about a tuned pipe. Like I said, I don't want to get into it too much theory right now. That's going to be a whole half-hour show, and I want to present that properly so I don't confuse people on that. Tuned pipes are quite simple in design. They're actually hollow, okay? And there's generally, and this is general, the most common pipe you'll see is a standard cone-to-cone pipe, which you have a cone starting at a small taper here, going to a larger taper here, from a larger taper back to the end. Now let me give you the definition of all this stuff, okay? Cone number one, this cone, the cone that comes from the engine. This is called the divergence cone, okay? And pretty soon we'll go through this and I'll explain where the word diversion comes from in the next segment. The next cone is called the convergence cone. So this is the cone exiting. And the end, finally, the little piece of aluminum here, is called the stinger. Okay. These are very common in our industry, this particular type of pipe. Let's go into a little bit of detail how they work. I'm going to show you a cutaway. Okay. Here's the inside of one of our older Pro wet pipes, and you can see how it works. The divergence cone leaving the engine, convergence cone, and then finally out the stinger. Real quickly, what's taking place here. Remember, go back to the theory. I think I touched on it where there was a point of the engine running on the exhaust cycle where the window is open at the same time the fuel charge comes in. I'm pretty sure I went over that. At this point, some of the fuel charge is gone. It blows out the exhaust. Here's where the tuned pipe came in. A lot of theory behind this. Okay? And the science is very vague also. Sound waves are pressure. It's like standing in front of a speaker. That's the best way I can, and I know I've spent many years in front of giant speakers, okay? If you guys don't know that, I have. There's a lot of pressure coming out of the speaker. It pushes the air. Okay. The exhaust produces a sound wave on an engine. The sound wave will generally, here's how a sound wave will work, how it will react. Leaving the engine, it will leave the engine, it'll expand, it'll ride the walls of this pipe. And then at this point in the center, when it goes into the convergence, it will compress. As it's compressing, there's two actions taking place. The sound wave itself and the pressure leaving is drawing spent gases out of the engine. At the same time, the convergence cone is sending a pulse back through the middle, a pulse pressure back through the middle, where when properly tuned, will put a false pressure wall against the exhaust window, keeping that gas that escapes, some of it, we don't know how much, back in the cylinder for the next cycle to fire. That's how they work. That's basically it in a nutshell. So you have exhaust gases escaping, which are also producing sound. They're traveling out, they're expanding, they're compressing, they're going out at the same time. The reverse cycle produced by the convergence cone, this cone, is sending a pulse back through the middle to put up a false wall at the exhaust. Okay? This is where they call tuning. And the reason that the word tuning is exactly that. Tuning is a note. You tune the pipe. You tune the wave, the speed of the wave, to refract back and catch that at the right time that that piston has the window open and some of the charge is missing. Now let me show you how to measure a pipe correctly. Okay, when measuring a pipe, this is very important. The header, right here, plays a very important part as well as the pipe. There's a couple ways to measure it. Generally, in the motorcycle industry, when you talk to somebody about measuring a tuned pipe on a two-stroke, this again goes for two strokes only, you guys, we basically would start at the center of the spark plug. But I started something several years ago that was easier for people. I would start at the actual exhaust window right here, the flange. And so when you hear somebody say, well, the M5 Warehouse Hobbies engine works great with their pipe at 14, let's say 14 inches. What they're telling you is, if you were to take a paper or a cloth ruler and you started at the flange, following center, this is very important, center of the manifold, the header, the pipe, when you got to the area where these two cones came together, that would be your 14 and a half. So if you called me and said, Tony, I have one of your pipes and I have the M5 engine, and I would ask you what kind of boat, because that matters, because, you know, maybe you have a catamaran, which would require a little longer pipe, because it takes a little bit more power, or a V, which we could shorten it up a little bit, and I'll get to that. What I mean by that is, as you increase the length of a pipe, you increase power. As you decrease the length, you increase RPMs. Each way you lose one or the other. Remember, there's a trade-off. I gain power, I lose RPMs. I gain RPMs, I lose power. That is all relative to the boat and also the propeller you require to turn. So if you have to turn a 75 millimeter because that's what your boat runs on, because if you put a 72 on, it's too small, your choice is pretty limited. You need to make as much power as you can to get as many RPMs. And that's how that works. So again, when you're measuring a tuned pipe, you measure from the flange on center, around the header, to where the two cones meet. And if you, like I said, I would ask you the questions and I'd give you a parameter. I'd say, well, what you've told me, I would tell you that my engine with my work and our pipe will run somewhere in the 14 to 14 and a half range. Maybe that's what I would say. So that tells you that your window of opportunity for properly tuning this engine is between 14 and 14 and a half inches. If you were to get a pipe with a 2-inch midsection, which are common today, especially for the aggressive racing engines, and we'll get into that when I do the tuned pipe segment, that would have a 2-inch band. So the band, there would be a 2-inch piece of pipe between the divergence and convergence cone. And that gives you a better mid-range. But if you ask me, well, how do I measure that? Very simple. Go to dead center of the 2-inch band. So if I told you that, well, the M6 is 13 3/8 to 13 and a half, you would start from the flange on center, and you would go to the center of the 2-inch band, and you would start, say, 13 and a half. Always start with the latter number. You can always work in. Another thing of importance is you want it, whether you buy from me or anybody else, the manufacturer should know what pipe and what proper length that would work on the particular engine that he did. He might not be able to get it exact, but the window is very small, and anybody that really knows what they're doing will be able to tell you that. Okay? That is very important. So be sure that you ask that information on pipe length, and make sure you tell them what type of boat you have, so you can get the right information. Okay, a couple more points of interest before I let you all go and finish up this show. With the tuned pipe, I told you earlier that you want to get a general basic idea where to start. And remember, the header is very important. And if you have I don't care what configuration you have a header, it can go forward, it can come back, go out, you still measure on center, and you use the entire header. So this sometimes, you might find out, well, now my pipe's too short for the boat. It doesn't come out the transom of the boat. Well, you don't build a boat and set your pipe just because it looks good coming out the back of the boat. You might as well have just a piece of pipe sticking out the back without a tuned pipe. Because if you're too long in the pipe or too short on the pipe, the motor or engine is not going to perform. So let's say you get in a situation to where you have a header going forward, coming back, and you're short of the transom. The stinger, this end, is very, very important, and it's calibrated in design. Now, I've done a lot of testing over the years because I've run into this situation, and I have to be able to tell you guys on how to rectify it, and myself on custom boats that we should do. I found that if you purchase a piece of 3/4 inch aluminum, thin wall aluminum, now remember the stinger is a 1/2 inch, 3/4 inch or 1 inch even, and you sleeve it over the top of this, you can use a piece of rubber, coupler, silicone, high temp coupler. I've extended them as far as 6 or 7 inches out of the back of the boat and not affected the performance of the boat. However, with that said, you just can't stick a piece of 1/2 inch over the stinger here and use the same ID. If you were to put a piece of 1/2 inch over that stinger, you'd greatly affect the way this pipe works. But I have found that 3/4 or 1 inch sleeved over with that piece of 3/4 or 1 inch coming out the back of the boat works fine. Another point of interest. The headers, generally, including ours, when we make them, I make them long. Because I don't know what guys are going to do with them, and there's different applications. That's why I said it's very important. If you talk to me and I tell you this is where the pipe's going to be, you basically have an idea how much header is going to go in that pipe. I hear this all the time. People make mistakes and not knowing. Because the header might be 8 inches long and you have achieved the right length, you can't have 3 inches of header sticking up into your pipe. That affects the performance. Remember how it works. Sound has to come out, expand, refract, come back in. That messes it all up. So what I tell guys, general rule of thumb, on these particular pipes, the ones that like we designed are very common in the industry, there's a double O-ring pipe, so they don't have a coupler. Tell guys, try to avoid any more than 1/2 inch, 3/4 of an inch past the second O-ring. So you have your first O-ring, your second O-ring. I wouldn't want that header any more than 1/2 to 3/4 inch forward of it. This will allow you a little bit of movement out and obviously in. And always set that number at the longest point of the pipe. You know, that's a good thing to do. That gives you that little bit extra if you need to pull it out. You know, you'll find yourself, you might have needed an extra 1/4 inch, now you don't have it. Okay? So that's pretty important with tune pipes. So it's very important that you have the right tune pipe, the right combination with the engine. And again, going back to the M5, you can get away with one of our wet pipes, absolutely, or the dry pipe standard divergence convergence cone. Let me tell you the difference in dyno power. And I was pretty amazed at this, because I didn't know up until last month. It was, we had an inertia dyno, and as you read on the website, the inertia dyno we're going to get into that. That's true horsepower is not what you're being led to believe. That's called peak horsepower, and it's pretty much not usable for us. Anyway, we're looking for constant horsepower that can turn a specific prop at the highest possible RPMs. Okay. Okay, before we finish up, I want to get into one more thing. I want to tell you how important it is to tune a pipe. We went through that. It is very important that you use some type of stop apparatus, such as a stop collar, which is right here. Again, we manufacture and sell these as well. This keeps the pipe from going forward. Our collar is dual purpose. It has a piece of material that can be bolted on, it comes with the kit, which anchors to the water fitting right here, and that keeps the pipe from going forward or backwards. If you were to run this engine and not have this pipe secured, the pressure is really great, the back pressure. It'll actually shorten the pipe as you're running. So we can't have that. Once you establish the right length of the tune pipe, it must stay. So whether you have a bracket on the back holding it securely or a stop collar, either or, this is mandatory. Anyway, we're going to dedicate a whole series, probably 1 or 2 shows on tuned pipes in the future, and stay tuned for that. But meanwhile, getting back to our M5 engine, I think you pretty much know enough now where you can maybe start carving on some of your old engines, and you can always call me, and I have no problem talking with you, and if you don't, you know, I have no problem with giving you some of the numbers. Practice a little bit using a moto tool. Your hand work, you know, the hand's got to be steady, and you have to know what's coming next when you start digging on a piece of metal, you know. Basically, it takes a little bit of practice. But I think I've given you enough information to understand what us engine builders do. And also, by doing so, this is pretty drawn out, good 2 episodes just on motor work. So the next time you talk to an engine manufacturer, you can pretty much respect, in some cases, of why they charge what they charge. There's a lot of work involved. And some guys that are on a smaller level, they do this by hand. I heard of guys spending 6, 7, 8 hours on an engine. That can possibly be. I mean, we don't here, we can never exist doing that here. But if you're limited to use of a Dremel tool and you don't have the fancy machines and equipment or the know-how how to use it, then this little guy right here, you could spend several hours with this little machine right here doing that job. So you can pretty much understand why some people, you know, they want to get paid for the amount of work, effort they put into it. And plus the know-how and all the years and how many engines it's taken them to learn. Anyway, I appreciate you joining me for this 4-part series. I hope you've learned something from it. I hope I didn't confuse you. I try not to. Like I said, you can call me at any time if you want to talk to me about it. The number I can be reached at in the office is 863-699-1231. I'm generally in the office Monday through Friday from 8:30 in the morning to 5:30. If I'm busy, you know, Pam or somebody here will tell you next time I come up in the office. Usually every day between 4 and 5:30, I come up to finish answering my emails and wait for you guys to call. I appreciate you joining in on Full Throttle RC, presented by Warehouse Hobbies. Again, my name is Tony Castronovo. Happy boating.